Okay, I want to do a couple weird ones quick and just show you a U sub. Some of this will come up in calculus. So this one kind of looks like a quadratic. So if you look at this, this is really 2 squared x minus 2 to the x minus 12 equals 0. So I could write that as 2 to the power you multiply. And you're like, I have no idea what to do. Okay, but it looks like a quadratic. So what we do is a U sub. So we're going to let U be 2 to the x, okay? Because that's your middle term, like kind of like in a quadratic, you have x squared plus whatever, 3x plus 4 equals 0 or something like that. The x is usually right in the middle, and this is x squared. So I'm going to let this be my U. All right, so if this is my U, I would have minus U minus 12 equals 0. That's looking a little closer to something like this. This guy is 2 of these, because do you see how I could take, I have 2 to the x and I have another one of them. So this is really U squared, because U squared would be, if I square that side, I get that. If I square this side, I get that, 2 to the 2x. Okay, this is factorable. I mean, this is beautiful. This is called a U sub because you sub into something that looks prettier. 4 and 3. Let's see. I want the negative on the 4 because I want more negative. I want the positive on the 3. Check your answer. U squared, negative 4, and positive 3 gives me that, negative 12, and I'm good. So again, remember, as humans, we can do quadratic and linear, which even quadratic end up being linear, right? If we can factor it here. Set this, add 4 to both sides, I get that. Add, let's see, negative 3 to both sides, I get that. Okay. The reason we do a U sub, this is a separate problem. The reason we do a U sub is to remind you that you have more math to do. If you accidentally put X here, you're going to think you're done. So you put a U so that you know you're not done. You got more work to do. So now what you're going to do is go back and do your U sub backwards at the end here. So this is really, I'm going to come over here. This is really what? 2 to the X equals what? 4. Now, that one I can just see. 2 squared is 4. I know X is 2. If you don't see it, you could do single exponential to single log. Logs eat answers, spit out exponents base 2. If you do log of 4 over log of 2, you're going to get 2 anyway. So however you go about that, you're going to get it. All right, let's look at this guy. All right, same thing. 2 to the x equals negative 3. All right, now this is impossible because 2 to the positive power is positive. 2 to the negative is positive because it'd be reciprocal, like a half, a fourth, an eighth. 0 would be 1. There's no way. That's why logs are positive, right? Like they eat positive numbers. There is no way 2 to the x, if you graph it, is looking like this, right? There's no way to get an output of a negative 3. We have an asymptote right there. So this one isn't going to give us an answer. So our only answer, this is the answer to the problem, is x equals 2. 2 would work, okay? We could check it. 4 squared is 16 minus 2 squared is 4, so that'd be 12. 12 minus 12 is 0. We're good. All right. This one, I mean, you could be like, oh, I want to isolate. Yeah, the problem is, even if you bring that x over, here you have a single exponential, but then you don't have equal to a number over here. Like for it to be a single exponential, you have to have like 2 to the x equals 7, right? You need a base exponent answer. Here we have a base exponent, and then, yeah, 2 parts not happening. So this one we're going to solve our decimals. So let me pause for a second. I'm going to graph it so we can look at it. Okay, I like to graph the left side to see what's happening over there and the right side, and then to see where they are equal, right? And so that x plus e to the x is this kind of weird red looking thing. And then this is a constant at 2. And so if I just, zoom in here, this crosses right there, okay? And so my x is 0.4. There's no way for me, at least that I know how to get it mathematically. I had a student try one time and it was not pretty. So maybe someone that, is a brilliant PhD in mathematics knows how to do that. But for me, I'm okay with just graphing it because it doesn't work out well. All right, I'm going to pause and do a couple more kind of more complicated types just so you can see them. Okay, I don't know if these are more complicated, but I guess we just didn't have time before. But again, I have 1, 2, 3 parts can't do. I can do single log, like I can do you know, single exponential equal to something. Well, that's easy. How about that? A single log, double log, but double log is like a log here and a log here. And you might be like, well, bring that over, but then there's still 3 parts. So what you have to do is use a log rule and be like, oh my gosh, like this is adding. So that means these things were multiplied, because exponent rules backwards, right? If you have x to the 6, x squared, that's when you add exponents. Equals 1. Now you're like, oh my gosh, this is a single log, right? You have a single log equal to a number. Single log, go to single exponential. Logs eat answers. Spit out exponents. This is your base. So you're like, oh, so the answer is this. The base was 5 to the first power. All right, so now, again, we know how to solve linear. We know how to solve quadratic. I'm going to multiply this out, either the box or FOIL. First, outside, inside gives you a to x. And last, if you do the box, great, you're going to get a trinomial. Bring the minus 5 over, because your goal is to set this thing equal to 0. So I get 0 equals x squared plus 8x. I think is that 7? Yeah, plus 7. Hopefully it factors, otherwise you got to do the quadratic formula. So 7 is prime, so that's lovely. I get a -7 or -1. Now, you have to check your answer. Just because they're negative does not mean they're bad, okay? It just means logs can't eat negatives. So a -7 causes a -1 here and a -5 there. That's a problem. He cannot. Logs have to be positive. Can't even be 0. Sub in a -1 here, you get 5. Sub in a negative here, you get 1. You're good. This works, okay? And if you type it in your calculator, hit enter, you should get 1. But just because it's a negative doesn't mean it doesn't work. It's just when you sub it in, you can't get a negative for input. Logs can only eat positive numbers, not even 0, and definitely no negatives. All right, let's look at this one. Kind of the same idea. Again, this is not a double log. This is 3 things. Can't do that. So what you do is you use your identities and you're like, ooh, I subtract when I'm dividing exponents. So you're going to write a single log and then you're going to put this as division. Okay. All right. So now you're like, okay, so what do I have? Now I have double log. So in a sense, you can do double exponents if you want. You could like, oh, I'm going to make this a double exponential. But really, if you have double logs, you can just take them away because they're going to cancel. Okay, kind of like if you have double exponential, you put a log on both sides, okay? So a lot of times we never show that. We just cancel. So we get x equals x plus 6 over x minus 4. Now, you can either clear the fraction. I like to turn something like this where it's kind of fractiony looking. I might cross multiply, but you could just do x minus 4 to both sides to cancel your fraction because we don't like those. Now, distribute, you get x squared, minus 4x equals x plus 6. If you cross multiplied, what you would do there is stick a 1 under there and then take this times this, x squared minus 4x, and this times this, 1 times x plus 6. Either way. All right, again, quadratic. How do you solve them? Isolate and inverse. The way you isolate is to bring over, so what is that? Ooh, Julie. -5x. Debt and debt makes more debt. -6 minus 6. So isolate, set equals 0. We're going to factor. 6 and 1 looks like that would be a nice 5. Let's see. I want this guy to be a negative because I want -5. So -6, I want this guy positive. Check your answer. X squared, -6x, positive 1. Yep. And -6, good. So I get 6 or a -1. Now, don't rule these out until you check. Okay, so let's go back to our beginning. 6 is okay here, 6 is okay here, 6 is okay here. So I think 6 is a good answer. -1 is not okay there. All right, it's okay here, but it's not okay here. All right, so -1 is out. So my only answer is 6. And again, if you want to check your answer, you know, you could just take your calculator and sub it in, just like you check any other one. So natural log of 6 is that answer. Okay, so I'm going to sub in 6. So natural log of 12 minus, what does that say? Natural log of 6 minus 2 would be 2. Okay, yep. And that makes sense because dividing 12 divided by 2 is 6. So that makes sense that that would work. All right, I'm trying to think if there's any other, if there's other ones you guys want to see me do, let me know. Probably the one that bothers people the most, I suppose. I don't know that it's that awful. But if I give you like x plus 1 equals 3 to the -2x, something like that. Okay, I'm sorry, that one's going to jump too because I had to edit out a little bit. All right, double, okay, exponential, I'm going to do a double log. And again, natural log is what you usually use. Bring down your exponents because of exponent rules. Bring down your exponent because of exponent rules, okay? All right, now distributive, because that's what we do when we want to multiply over a binomial. And 1 times that, you don't need to write the 1. And then here I can drop the parentheses because there's no add or subtract in there. All right, now you want your x's on one side, numbers on the other. So I'm going to add 2x ln of 3, add 2x ln of 3, and then I'm going to go ahead and subtract that ln of 2, natural log of 2. Get that over here. All right, so I get x ln of 2 plus 2x ln of 3 equals a negative ln of 2. All right. The only way to go from 2x's to 1x, if they're not like terms, is to factor it out. So again, I'm going to pull that x out from both of those, okay? And so when I pull it out, I get ln of 2, what is that? Plus 2 ln of 3 equals negative ln of 2. And then to get rid of multiplying, I'm going to divide both sides. Ln of 2 plus 2 ln of 3. All right, so x equals negative ln 2 plus 2 ln 3. All right, let's convert that to a decimal just to see what that is. So negative, sorry about that. You couldn't see my screen very well. This is a pain to type in because you need nested parentheses and stuff. And actually the first time I typed it in, I'm like, crap, got the wrong answer, had to fix it. So I would recommend, I think Desmos is just a little bit prettier to type in because you have that nice little fraction. You can hit the A over B right at the beginning. You don't have to worry about nested parentheses and stuff like a TI. But anyway, here's your correct answer when typing that in. And then if I go to Desmos graphing, I graph these as 2 separate functions, okay? So I graph the left and the right. So here's one side, and then here's the other side. And you want to know where they cross, which is right there, okay? So however you solve that, you can check your answer with graphing. You can check it by subbing it back in. But, there are ways to check. And just, x can be negative because we're dealing with exponents. So exponents can be positive, negative, 0, any of that. So hopefully this helps you guys. Take care. Bye-bye.